Momentum and impulse. Here we're going to talk about conservation of momentum and what momentum is, and also what is impulse. By the end of this lesson, we'll be able to describe the linear momentum of an object, describe the behavior of a system using conservation of linear momentum, and describe how the selection of a system determines whether the momentum of that system changes. To meet these objectives, we have to know that the linear momentum of an object is defined as the equation P, lowercase p, equals m for mass and v for velocity. Momentum is a vector quantity and has the same direction as the object's velocity. Momentum can be used to analyze collisions and explosions, and we should know the correct application of conservation of momentum can be used to determine the velocity of a system immediately before and immediately after collisions or explosions. That word immediately means the second just before the collision starts or just after the collision ends. A lot of new vocabulary here, some review. Conservation, remember, means all the stuff in the beginning has to equal all of the stuff in the end. We've used conservation of energy, where we said all of the energy in the beginning had to equal all of the energy in the end. Now we're going to build on that same thought process. Remember, a vector is a thing with a magnitude and direction that can be represented with an arrow whose length is proportional to the magnitude and points in the direction of the quantity. Magnitude means absolute value, how big or how much something is. Momentum, a vector quantity that is the result of an object having both mass and velocity. The unit is the kilogram times meter per second. Conservation of momentum, here it is. All the momentum or momenta in the beginning has to equal all of the momentum or momenta in the end. The sum of the momentum in the beginning has to equal the sum of the momentums in the end. This is used for collisions, crashes, explosions, those sorts of situations. A collision is two or more objects crashing into each other and resulting in either two objects or one object if they stick together. An explosion, that means one object instantaneously becomes multiple objects. This does not necessarily need to be violent. It could just be two hands coming apart or two people pushing off of each other. Could also be an explosion. An open system is an object or collection of objects that we care about that experiences an external force. An elastic collision is a collision where momentum and energy are conserved. An inelastic collision, a collision where momentum is conserved and energy is not. Impulse, the change in momentum brought about by a force acting for some time. So what is momentum? Let's take a look at an example. A cart of mass 10 kilograms is moving 10 meters per second to the right. We would say this cart has momentum. It has a mass and a velocity. Velocity is speed and direction. Usually we're going to use right and up to be positive directions. To remind ourselves, we can draw this coordinate system as to the right. So 10 kilograms, there's our mass. 10 meters per second, there's our speed. And right, there's our direction. Direction could also be positive or negative. North, south, those sorts of things. We can model this momentum as a vector, where the length of the vector is going to represent the magnitude of momentum. The more momentum an object has, the bigger the arrow would need to be. To change momentum, a force must be exerted for some amount of time. Cart moving and crashing into a big black wall, that means that black wall is a force acting for some amount of time, which is impulse. Impulse is the change in momentum brought on by a force acting for some time. In math terms, we have this equation, F net equals the change in momentum over the change in time. On your equation sheet, you may see this rearranged to be your change in momentum equals the net force times the change in time. Conservation of momentum, all of the momentum in the beginning has to equal all the momentum in the end. We're going to use this problem-solving strategy whenever we have this come up. And we'll have this come up when there's a collision or explosion taking place. So first thing we need to do is identify that a collision or explosion has taken place. Then we'll draw our coordinate system to show our directions, up being positive, down being negative, or down being negative, up being positive, whatever works for you. Write a conservation of momentum equation. All the momentum in the beginning has to equal all the momentum in the end. Substitute your momentum variables and substitute the quantities, or just plug in your numbers. Let's see that in action. But first, when do we use it? We're going to use this when two or more objects crash or collide. They interact with each other. When one object becomes multiple objects from some interaction, an explosion, like fireworks. In physics, we use subscripts to tell the difference between similar looking symbols, VI and VF. We perhaps already know that. Don't let all of these subscripts intimidate you. A lot of times things will just be zeros and cancel out. So let's look at an example. Cart of mass 10 kilograms is moving 10 meters per second to the right. A second identical cart moves 5 meters per second to the left. The two cars stick together. We can use conservation momentum to predict the velocity of the two cars after the collision. So we recognize there's a collision happening. We don't know if the car is going to be moving to the left or is it going to be moving to the right. We're going to have to solve it to figure it out. There it goes. All right, back to our problem solving strategy. Remember, momentum is a vector, so positives and negatives matter. We'll start with our momentum in the beginning has to equal momentum in the end. We have two objects in the beginning and only one object in the end because they stick together. So we have two momenta in the beginning and one momentum in the end. Substituting in the momentum equation, mass times velocity. Notice the negative sign. Because the second mass is moving to the left, I used a negative. I used the momentum 1 minus momentum 2 equals the combined mass, because the two objects stick together, times the final velocity. Only one velocity because there's only one object in the end. There are a ton of subscripts here, so you have to write neatly or you will confuse yourself. Plugging in the numbers, hopefully you get 2.5 meters per second. Because the answer is positive and we drew positive to the right, that means we are moving to the right after this collision. And that makes sense because we have more momentum moving to the right than we do moving to the left in the beginning. Another example, a cart M1 of mass 10 kilograms moving 10 meters per second to the right. Identical cart M2 moves 5 meters per second to the left. Two carts collide and then move in opposite directions. Derive an expression for the final velocity for M2. So here's what that looks like in cartoon form. They move in opposite directions. Two separate objects. So there's a collision that's taken place, so we need to start by writing a conservation of momentum equation. All the momentum in the beginning has to equal all the momentum in the end. Substitute our momentum variables and then solve for whatever it is we need. There's our conservation momentum equation, listing out all of the momentums in the beginning, equaling all of the momentums in the end. We have M1 times V1I plus M2 V2I. You can also, at this point, you can use subtraction here if you like. I didn't, and that's okay. If you want to use the negative sign right there in between those two momentums, that's absolutely perfectly fine. Adding a negative or subtracting a positive is the same thing. So whatever works best for you. I just kept it all to be positive, knowing that the final velocity for M2 is going to be to the right because it moves in opposite directions. Next thing, because the two carts are identical, I could factor out the m's from each side, which got them to cancel out, and then just solving for V2F. So that's it. Next step, make sure you complete practice. Do your test for understandings, whatever problems are assigned. For more practice, there's your AI prompt. Ask each other, ask me, and keep asking until you get it.